Okay, December 2012, question 5. It's all about right angle triangles. Could be Pythagoras, could be trigonometry, could be something else, and in fact it will be something else as well, as we will see. So it's how far is it to the island? Clara and Emil are standing on land and looking at the flag out on an island. They would like to know the distance to the flag at point E. So they've taken some measurements between points A, B, C, and D. You now have to use these measurements. Okay, so they've taken measurements on land where they are, and they're going to use those measurements to figure out the distance across the water to the flag on the island. So it says points A, B, and C lie on a straight line, and points D, B, and E at the flag lie on a straight line. The relationship between the measurements on the figure A, B, C, D, E are not drawn correctly. Okay, so this is just a sketch. It's not a correct diagram. So for example, if you look at the 4 and the 20 isn't 5 times bigger than the 4 as it should be. So it says draw the figure A, B, C, D, E, in the correct measurements. It says you can use IT tools such as GeoGebra. I recommend you don't. I recommend that it's easier and you can come up with a neater result doing it on graph paper. So it'll look more like this when you do it. So you can see how that's very different to the one in the sketch. And it's just important that it's neat, that it's labeled correctly with the real life measurements and not how many centimeters it is on your paper. And you ought to say what the scale is as well. So it might be 1 to 200, depending on how you draw it. Question 5.2. Why are triangles ABE and CBD similar? Okay, so if two things are similar, that basically means that they have the same shape, but they don't have to be the same size. So they are similar because they've got the same angles, essentially. You won't get the full marks just for saying that. You need to demonstrate why they have the same angles. So the angles on points A and C are both 90 degrees. They've told us that because they've put little square marks on A and C telling us that they're both 90 degrees. The angles at point B, that's here where they cross over, are equal because, that's called opposite angles in English, Topwinkler. They're always equal. So when you've got two lines that cross over, then the angles opposite each other are always equal. So you've already got two sides in each triangle that you've demonstrated are equal. So the third side must be equal to make the whole thing add up to 180. So I've just written the third angles at D and E, D here and E there, are therefore also the same. So I would hope that's enough of an explanation to satisfy anyone marking it. 5.3. How many meters are there from point A on the beach, here, to point E on the island? Now they've led you into this question a little bit by talking about similar triangles, and you need to use the fact that the two triangles are similar in order to get the answer to this one. So it's nothing to do with trigonometry or Pythagoras. It's all about similar triangles. So the point to this is that you've got a 12 and a 4 and a 20 and a missing one, and because the triangles are similar, then you can say something about the 12, the 4 and the 20 to calculate the missing one. So AE divided by CD equals AB divided by BC. I'm doing this on my rough paper, that's why it's yellow. So I'm saying AE, the one that we want to know, divided by CD, the one that's like it in the other triangle, is going to be the same as AB, that's the 20 in the big triangle, divided by BC, that's the 4 in the little triangle. Okay, so the missing one divided by the one that looks like it in the small triangle is going to be the same as the 20 divided by the 4, because the triangles are similar. So putting in all the numbers, AE divided by 12 equals 20 divided by 4. Multiply both sides by 12 to get AE equals 20 times 12 divided by 4, and that's 60. So the missing side, AE, is 60. Now just notice the way that I set this up to start with, so that the thing that I was looking for was on the top. Okay, so I did the thing I was missing divided by the one that was like it equals 20 divided by the one that's like it. Just makes the algebra a little bit easier to deal with if the thing you're missing is on the top. So as a neat answer, I've written 5.3, distance AE equals 20 times 12 divided by 4, which is 60. I notice I've written centimetres there. That should, of course, be metres. Which angle would you measure in order to use the function tangent in English, tangens in Danish, in order to calculate the distance from A to E? You have to justify your answer. Okay, so we're missing AE, that's that one. We know the 20 there. So if we're using tan, that's opposite divided by adjacent. So if we use this angle here at B, then the thing we're trying to find out will be the opposite, and the 20 will be the adjacent. So to use tan, it should be that red angle there at B. So I've written, I would measure angle B because I know that AB is 20, and tan of B equals AE over AB. Okay, don't stress too much if that's a bit above you. That is the kind of question that will separate a 10 from a 12. So if you're looking for a 12, you're looking to get that question right, but it's not for everybody. Here are my marks, noting, of course, that question 3 should say meters and not centimeters. 4, 3, 4, 4. So for question 5.3, where I've made that mistake, I might just lose 1 mark out of the 4.